Right, kia ora whanau. My name is Mr. C. This is my very first video of lockdown. I've decided that I'm going to use some of my time from home to make a few videos around online learning. Hopefully, the goal is that these will ease the transition of students and parents getting around the idea of what online learning looks like at home. I'm going to start off with a maths video today. Basically, I've had got this idea that I want to try and go through as many of the math strategies that we teach in the classroom as I can, giving examples so that parents, if they are working with their kids at home, can make sure that we're being consistent and that what's happening at home is the same as what would be happening within the classroom. So the first math strategy that I'm going to be taking you through today is called Place Value Partitioning. So if I go into my sketch pad here, and I'm just going to make this video a little bit smaller here. I'm going to get rid of that altogether actually. I've got my first example here. Now, the very first thing is I've put this into a word problem. It's really important that kids are doing as much math as they can through problem solving or word problems. A key thing that they need to do here is read the question, and then they need to have the actual comprehension skills to work out what the question is asking them to do. So this question says, Aroha and Daniel went to the shop to buy supplies for the lockdown. They purchased a torch for $34, groceries costing $156, and 4 puzzles for $72. How much did they spend altogether? Now, underneath here, I've highlighted the 34, the 156, and the $72. Now, the key thing there is that those are really important pieces of information. They are going to help us to solve the question. And the last bit I've put down here is the spend altogether. Now, the reason I've done that is because I may know the numbers, the 156, the 72, and the 34, but is this question asking me to do addition, subtraction, multiplication, or division? Now, when it says spend altogether, that's helping me to work out that it's going to be an addition problem. I need to add those numbers together. Now, down here, I've put my important figures, 156, 34, and 72. Now, when I do place value partitioning, I split these numbers up into their place value columns. So in the dark blue, I've highlighted any numbers that are in the hundreds. So I've only got that one there, 100. Now in my tens columns, I've got the 5 of 50, the 3 of 30, and the 7 of 70. And in the ones, I've got the 6, the 4, and the 2. Now what I've done here is I've put those groups together. So my hundreds, my tens, and my ones. So I've got 100 plus 0 for my hundreds equals 100. My tens, I've got 50 and 30 and 70. Now I know this makes 150, and the way that I did this was I looked for groups. So I know 70 and 30 makes 100 because I know 7 and 3 makes 10. Add on my 50 gives me my 150. And then down here, 6, 4, and 2, 12. And I know that because I can do 4 and 2 makes 6, and 6 and 6 is 12. That's my doubling. Or I know that 6 and 4 makes 10, plus my 2 makes 12. Now that I've split those all up into smaller, more manageable bits, I can put them all together again. So I've got my 100, plus this 100 is 200, plus the 50 is 250, plus the 10, 260, plus the 2 is $262. So that would be my final answer here. So if I wrote that in, 262. Now, I've done that with working. The goal is that this place value partitioning strategy is a great way for kids to transition from a written strategy to a mental strategy, so that if they didn't have a pen and paper with them and they were at the grocery store and they needed to work out, or anywhere that they were doing some simple addition, they'd be able to use place value partitioning to help them actually solve that. Now, that's place value partitioning for addition. You break up all of the numbers that you're adding. For subtraction, it is slightly different. So I'm just going to open up my place value partitioning for subtraction here. The big difference is that when you are doing place value partitioning subtraction, you only split up the number that is being taken away. So I've got Marcus had 174 toy cars. He lent 52 to his cousin Taiha to play with. How many toy cars does Marcus have left? So again, I've done this as a word problem, and I've highlighted 4 pieces of important information. My 174, lent, 52, and have left. So my 174 and my 52 are going to be my numbers, and my lent means I'm getting rid of those. I don't have them anymore. That shows me that it's going to be a subtraction problem. And the last thing I have there is have left. So again, it's showing me I'm taking those away, and the answer I'm looking for is how many left over will Marcus have. So what I've done here is I've got my 174 take away 52, and I only split this number, and I split it into its place value. So in 52, I have my tens and my ones column. My tens columns, I've got a 5, so that's 50. And in my ones column, I've got a 2, which is 2 ones is 2. So the first step is I drag my 174 down and I take away the 50 from that. So it's basically going to be 174 take away 50, 70 take away 50 is 20, so 124. I then take that 124 down here. And now I've got my second and last step here, which is 124 take away 2 is 122. That is it. That has to be my final answer. So I can write that in up here, 1, 2, 2. Again, the big difference is that you are only splitting the number that you are taking away for subtraction. Addition, you are splitting both numbers. Subtraction, you are splitting only the number that you take away. The key also thing is that when you've done your first step, that number drags down to become the next part, which your next number is taken away from. I've also done here a whole range of example questions. I know that you're not going to have this doc, but you can pause the video and have these here. Basically what I've done is 1 to 10 are addition problems, and then 11 to 20 are subtraction problems. They start easier and they work their way into being a little bit harder. You can see that I've also done a few decimals examples. Decimals for place value partitioning works exactly the same. You split your numbers up into their tenths, hundredths, thousandths, and then put them back together. And they've done that with subtraction as well. And then this last one here is 43 take away 57, which is actually going to end you up into negatives. So have a crack on at that one as well. That is our first video on place value partitioning, team. I really hope you've enjoyed it. Hopefully it's been helpful. Crank through those 20 example questions. Should be able to work out, and parents should be able to work out the answers for those. If you do want to, get in touch with me and send them through, and I can definitely have a look at them and give you some feedback, or send them through to your teachers, various teachers. I'm sure that they'll be happy to do that. I will try and get some more videos up. Hopefully they're not all maths. I'm a very keen sports person, so I'd love to get some PE lessons up, maybe some reading, maybe some science. My next video will probably be around rounding and compensating in maths. All right. Cheers, team. Kia kaha. Stay safe, stay well, and see you later.